Okay, this is lesson 13. The objective was divide decimals by single-digit whole numbers involving easily identifiable multiples using place value understanding and relate to a written method. Okay, we're going to use a lot of our math facts and our unit form in order to solve a lot of these. You can see in number 1 says 3 groups of 5/10 equals 1 5/10. What I like to do over here first is look at the problem. And it says 1 5/10, which I would change that to 15/10 divided by 3, and that's going to equal some tenths. And looking at this, I know 15 divided by 3 is going to be 5/10. So we can write it in decimal form. Over here, using our math facts, if we work backwards, we know 5 times 3 is 15, so 5/10 times 3 would be 15/10. So 3 groups of 5/10 equals 1 5/10, or also 15/10. On B, the same thing. We're going to take our basic math facts. Here we have 24 hundredths, so I'm going to write 24 hundredths divided by 6 equals, and it's going to be something hundredths. Well, I know 24 divided by 6 is 4, because 4 times 6 is 24. So I know 24 hundredths divided by 6 is 4 hundredths. That means 6 groups of 4 hundredths equals 24 hundredths. Now up in A, they've already done it for us. Let's take a look. And here they're using the distributive property. They're taking this 9 36 hundredths, and they're going to split it up and divide each one by 3. So here we have 9, such as here, ones divided by 3, plus 36 hundredths divided by 3. See, these are compatible numbers, and they're compatible numbers because they're both divisible by 3. So now we have 9 ones divided by 3 gives us 3 ones. 36 hundredths divided by 3 gives us 12 hundredths. So we end up with 3 and 12 hundredths. In B, we can see we have 36 and 12 thousandths. So I know I'm going to take 36 ones, and I like putting parentheses so I can see the difference. And I can see that it's not divisible. 1/10, excuse me, 100th is not divisible by 3, but I know 12 thousandths is. So I want to put 12 thousandths divided by 3. Now I can use my basic math facts, which is 36 divided by 3, and that's going to give me 12 ones. 12 thousandths divided by 3, which is going to give me 4 thousandths. And we write that as 12 ones and 4 thousandths. On C, we have 3 and 55 hundredths divided by 5. And they're looking at tenths. So we know if we're going to write it in tenths, we're reading the number to the tenths position. And that gives us 35 tenths divided by 5. And that leaves us 5 hundredths divided by 5. Because we know 35 tenths divided by 5 is going to be 7 tenths, plus 5 hundredths divided by 5 is going to be 1 hundredth. So we end up with 7 tenths, 1 hundredth. On D, when we're looking at this, we're looking for compatible numbers. I can see 3 ones is not compatible, but 35 tens is. So I'm going to go 35 tenths divided by 5 plus, and I have 45 less, and that is a multiple of 5, so I'm going to That's 45 thousandths divided by 5. Well, I know 35 tenths, 35 divided by 5 is 7, so 35 tenths divided by 5 is going to be 7 tenths plus 45 thousandths divided by 5. Well, 45 divided by 5 is going to be 9, so 45 thousandths divided by 5 is going to be 9 thousandths. And we write it standard form. We know we have 7 tenths and 9 thousandths. Question 3 says find the quotients, then use words, numbers, or pictures to describe any relationship you notice between each pair of problems and the quotients. Well, we know 21 divided by 7 is 3 because 3 times 7 is 21. Well, if I know 21 divided by 7 is 3, 22 and 1/10 divided by 7, or 21 tenths divided by 7 is going to give me 3 tenths. Now, if you notice, all the digits are the same. It's just the placement of the decimal point that made the difference. Same thing in B. They did 48 divided by 8 was 6. So you can check yourself. 6 times 8 is 48. So that means 48 thousandths divided by 8 is going to be 6 thousandths. Are the quotients reasonable? Now, the best way to find out if quotients are reasonable are to multiply, use your basic math facts. Here we're saying 54 hundredths divided by 6 equals 9. So a related math fact would be 9 times 6, which equals 54. You notice this is 54 hundredths, where this is 54. So 54 is 100 times greater than 54 hundredths. So it's not reasonable. B says 54 tenths divided by 6 equals 9 tenths. So we can go the other way and we can say 9 tenths times 6 is equal 54 tenths. And we can see here both these are exactly the same, figuring 54 tenths, so this is reasonable. Okay, and C, we have 54 divided by 6 equals 9 hundredths. Well, if we turn around and we go 9 hundredths times 6, then we know that would be 54 hundredths. So we can see that 54 is 100 times greater than 54 hundredths, not reasonable. Bottom one here says a toy airplane costs $4.84. It costs 4 times as much as a car. What is the cost of the toy car? Now, if you don't see this, if you draw a tape diagram, and the top would represent the toy airplane, which is $4.84. And it's saying that the airplane costs 4 times as much as a car. So there is one car right here, car. And that's where they're getting the $4.84 divided by 4 to tell you how much the toy car is. Now, we're going to break this up, and you can see we have 4 ones, and we're going to divide that by 4. And then we have 8, which is 8 tenths divided by 4, plus 4 hundredths. divided by 4. Now this is something you can do when every digit is a multiple of your divisor. You can distribute it out. Now you have 4 ones divided by 4 is going to be 1 1 plus 8 tenths divided by 4 is going to be 2 tenths plus 4 hundredths divided by 4 would be 1 hundredth. So we can say that $4.84 divided by 4 equals, we have 1 1, 2 tenths, and 1 hundredth. So our last word problem, Julian bought 3.9 liters of cranberry juice and Jay bought 8 and 74/100 liters of apple juice. They mixed the two juices together, then poured them equally into 2 bottles. How many liters of juice in each bottle? So first I can see there's 3.9 liters of cranberry juice, 8.4 liters of apple juice. Mix the two together and pour them into 2 equal bottles. How much juice is in each bottle? So if I do a tape diagram, I'm looking for the total here first, because it says that they had 8.74 liters apple juice and it's 3.9 liters of cranberry juice, and I'm looking for the total of the two first. So I can tell that I have to add them together. So we have 8 and 74/100, and we have 3 and 9/10. Now I lined up my decimals, I lined up my place values, I'm putting a place value holder in, and 4 plus 0 is 4, 7 plus 9 is 16, carry my 1, 8 and 3 is 11, 1 is 12. So I know we have a total of 12.64 liters of juice. Now it says that they divided them equally between 2. So now I've got my same one, and it's still going to equal 12.64 liters, but it's equally between 2 then. And I want to know how much is in 1. So I can see I have 12.64 divided by 2. And I can see all this are multiples of 2. So I can go 12 ones divided by 2 plus 6 tenths divided by 2 plus 4, no, not going to be hundredths divided by 2. Well, 12 ones divided by 2 is going to give me 6 ones plus 6 tenths divided by 2 is going to be 3 tenths plus 4 hundredths divided by 2 would give me 2 hundredths. So I can see that each juice is going to have 6 and 32 hundredths liters.